Good morning, guys. This is Mr. Cooks. Happy Friday. I know you guys. Hopefully, you guys are doing well, and hopefully, you got the post where I submitted some material for your information, so you can let you know what topics we would be covering for the remainder of the school year. And it looks like this, and you can see this where it says circles and conics. That's where we are right now. And today's assignment will be um, I'll be teaching you how to solve problems involving inscribed quadrilaterals. So, inscribed quadrilaterals for semester 2 class only. And before we get into details, in the material section, you always can, if you're able to print materials and then annotate while you watch the video, you can do that as well. That will help you, jot down questions that you have or what have you, and you can pause while you're taking notes, or you can just, take notes in your notebook as you watch the video and pause when necessary. So, whatever is more appropriate for you and for your learning style. So, before we um, get into actual problems involving quadrilaterals, I just want to give you some key points that are going to be involved in this video. And if you notate, again, in your notes, you can just use annotation, or you can pause this video and write this down, but whatever is appropriate. Full circle is 360, remember that. Half circle is 180 degrees. And the sum of the angles, which are four angles, of a quadrilateral is 360 degrees. And something very important that I'm going to give you that information in annotation form in a few minutes, but the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So again, that word, you hear that word intercept, several times in mathematics. It's not necessarily the same as a y-intercept, but you understand why they call it an intercepted arc when I give you the problems, okay? So again, you can pause this video here if you need to write notes in regards to this or annotate before you move on, okay? So the first thing we're going to look at is, before we get into an inscribed quadrilateral, let's identify what's an inscribed arc, or in fact an inscribed angle. Because remember, quadrilateral has 4 inscribed angles to form the quadrilateral. So let's quickly look at this figure here. You notice that, first of all, I'm going to see what you notice first. While you're thinking, I'm gonna see if you can at least jot down. Let's see. Let's say four words, mathematical geometric terms that can be written down just looking at this picture. I'm gonna give you about 10 to 15 seconds to think about it and see if you can write it while you're thinking. 4 words. Okay, I'm back. So, and I can hear some people in the back. I can see you, and I can hear you right now saying, "Oh, I wrote that. I wrote that." Let's see if some of you wrote the word chord. And let's look at this picture. Do you see a chord? Let's name a chord. Yes, the answer would be TU is a chord because the endpoints are on the circle. TV is a chord. Okay. I'm going to write the word arc. I'm going to write the word circle, obviously. And you could come up with any other words. You know, there are several other words you could have come up with. You could have come up with point. You could have come up with vertex. Those are the four more, not the most important words, but it's, did anyone think you notice what part of this figure is an intersected arc? Anyone? Look at it again and see if you can identify intersected arc. Okay. So as you see these chords, these are two chords, right, that form the angle UTV. So this arc, these are arcs out here. All right, you have several arcs. Okay, you have a minor arc. If you remember, UV is a minor. Major, you can actually have a UV major as well, from all the way around that side. You have TU is an arc. Okay, we have TV is an arc, and we have UV is also an arc. And I actually named the major arc, and I said, no, I said VU, but actually a major arc would involve all letters, so it'd be VTU all the way around this way. That gives you an indication what direction you're going as well. If you're going in this direction, it'd be VTU. So you use three letters to identify the major arc, the direction going in that direction here. And this is just a review you guys already had lesson on major arc and minor arc, and just going over it again before I get into inscribed quadrilaterals. So the intercepting arc, I'm just going to do like little lines like this, okay? This is actually the interceptic arc. So these two chords, if I extend it to make it like an actual angle, it intercepts the circle at these 2 points, U and V, okay? And the arc that's between these two letters is the intercepted arc. So that's why I'm gonna annotate, okay? I don't have enough that much, so I'm just annotating. This is represent the intercepted arc, okay? And if you remember the rules that I gave you, I'm going to pick it up, the last one, which states that, and I'm going to write this down, the inscribed angle, right? So I'm just going to write the measure, right, of angle UTV is equal to half, right, of the arc UV, okay? I'm sorry if I kind of try to write it neat as possible. So in other words, okay, this number here, which is the arc, right, is twice as much as the angle. So if I say that this particular angle, which is 45, right, this is the angle, right? Then the measure of the arc, right? The measure of the arc will be twice as much, which would be 90, okay? So if I ask for what is the measure of this arc, then you say 90 degrees. And conversely, if I say the arc, I'm going to erase so you can understand how it looks on an actual assessment, where they'll write 90 outside, right? So again, this is not a right angle. When you see 90, all right, and we're gonna talk about radians and get back to clarifying the difference between a radian and degrees, et cetera, et cetera. But if you look at this number 90, that represents the measure of this arc, okay? Just 90. So that means that the measure of this angle will be 45. In essence, that's what you're using this rule when you're giving 4 angles, okay? So if I actually add, oh, that's ugly. So if I add 4, and I'm gonna use the red pen so it looks a little bit better. So if I actually add a line here and a line here, then I'm actually drawing a quadrilateral inside, and then you have to identify. And I'm taking my time with this lesson because I know you guys have to regurgitate the information that you have when we did inscribe angles. And we have a problem here. And I want you to just quickly look at the angles and identify the intercepting arcs. Just imagine that the intercepting arcs for each. Okay, so a problem like this can be written in several ways. Several ways. Okay, and I'm just writing this down so you have the information. Okay, now I have a setup, and I want you to find x, which is the measure of angle ABC, if you see here. And I want you to find y, which is where the vertex D is, which is the measure of ADC. And I want you to quickly look at this and see if you can think about where do we start. And there's no one right answer where do you start, correct? So 2 things we can conclude: that these 4 numbers should equal to 360, right? The arcs, intercepting arcs, is half of the angle, which is called the inscribed angle. And we have 2 inscribed angles given. And I actually gave you 1 number on the outside, which represents the measurement between A and D, which is this arc here. Okay? I hope you can see that. Okay? Now, where I would start by using the number on the outside first, because that's a little more obvious one, right? So we can say, okay, if AD, which is these 2 points, right? Okay, and I'm gonna have to, actually this is ADC, I'm sorry. ADC, so I'm gonna write it down because that's my fault. Okay, so I'm gonna write ADC, and I'm gonna put a little arc here, right? Which is the way, right? It's equal to 200, right? So if ADC is equal to 200, I'm gonna write 200 degrees. So I'm gonna annotate that for you, okay? So I'm gonna use a red. I'm just gonna go, kind of messy, but A, B, C. So that's from here all the way to there. So I'm gonna stop there, and I'm gonna identify that's A, D, C, okay? Which I wouldn't call it AC because you don't know what direction it's going, right? So I went A, D, C. So talk about this arc, all right? So which angle we gonna find using ADC 200? Okay. I don't know if you noticed that this angle is connected to this point and this point. And this angle here, we can use this number 200 to find this angle, okay? Which is the rule. An inscribed angle is half the measure of its intercepted arc, okay? So we can conclude that this is 100. So x is equal to 100, okay? So if we know x is equal to 100, do we have to do anything else in regards to using that particular rule? Do we have to use any other arcs? I mean, you can play, you don't have to, right? What can we do? Think about it. Remember this page here? What fact can we use? I heard someone say it. The sum of the angles of a quadrilateral is 360. Therefore, if we know that this angle is 120, this angle is 60, this angle is 100, then we can use just simple mathematics to find the missing angle. You see how it looks difficult, but really all you had to do is use that one rule, and then the fact that the four angles, just like I said, is equal to 360. So we can add, right? Right? You can just add them, right? And then you end up with 280, I believe, correct? All right, that's step one, right? And then step two, we're going to just use what we know to find y, okay? So we can do 360 minus 280, right? Which is 80. So the measure of y is equal to 80. So if I was giving you a question, asking to find the measure of y, or x and y, then you have to use two steps. I'm sorry, I didn't make that mess again. So this would be 80, okay? 80, 80, 80 is your answer, okay? So this, this could easily be a 2 or 4 point question where you have to find, or just ask you, it may just be, say find y, but then you can't find y until you find x. So it's like a, multi-step question. All right, so you have to think about that. You're not going to go directly to y sometimes. Obviously you could find y by knowing A, B, C, this entire arc. And there may be situations where one student might solve this same problem one way by finding A, B, C first, then find y directly without using that 100, or the fact that the sum of the quadrilaterals is 360. And another student might do it the way I just did. Depends on what's given in the question. Again, you use what's given, and then you use the facts that I gave you here that I'm sure you guys either annotated or you wrote in your notes for further use or for studying purposes to solve a question. So I have one more question for you guys using a fact that we didn't use yet, and then that's going to be the end of this lesson. Just make sure that you annotate wherever possible or copy notes wherever possible. And this drawing is going to be a little messy probably, but I'm going to try my best. Okay, so this is a circle, beautiful circle. Good job, Mr. Cooks. This is a center of a circle. Okay, now I'm going to draw a chord. Notice I said chord, right? There's a special name of this chord. What it's called? Yes, diameter. And you notice that the diameter divides it in half, okay? Then I'm going to draw I can do it either side, it probably don't matter. I'm gonna draw an inscribed angle here, right? Okay. Try not to make it a mess. Okay. Now, I'll let you look at that right quick, or if y'all want to sketch that out. Okay, now I'm gonna label this point here A. I'm gonna label this point here B. I'm gonna label this point here C. Okay. Now, BC is an arc, AC is an arc, AB is an arc. Okay. Now I'm gonna write that. Sometimes it'd be annotated, or sometimes it would be noted in the diagram. But I'm gonna just write out arc AC is equal to 160 degrees, right? So you're gonna have to, like, if you had a question like this, I'm gonna say, right? And then you will be asked, okay, find arc BC, right? So you will be asked to find arc BC. So first thing I would do, I would annotate. Always annotate, 160. I'll write that there, okay? Now, believe it or not, a diameter form, those are two, this is a chord where it actually form a straight angle. Okay, remember, or it divides a circle into half. Okay, so if this is 160, you can basically, some people use conceptual knowledge to answer that question. Say, well, what's the measure between B and C if this arc is 160, right? You can just use the facts that I gave you earlier. And that's what you're going to do, use the facts. I'm going to go back to this picture again. Half a circle is 180. So a diameter actually form half of a circle. So that means what's missing, this here is what's missing, what you're looking for, BC. The sum of BC and AC should be 180. So it's simple mathematics or conceptual knowledge where BC, arc of BC is equal to 20 degrees, okay? And some question like this baffles some people because they say, wait a minute, you didn't give me this angle right here. How am I gonna find this arc? I should be given this angle when you're not really noticing that there's a diameter given that divides it in half, okay? So these are the problem solving skills. You have to annotate, you have to use the information that you have and to try to solve the problem. Now, so it is true if this is 20, there may be a part B that might you find the angle X, right? So let's say if this is 20, then what would be that angle? What would be angle B? So that'd be an extended question, okay? Think about that. If this is 20, then what will be the measure of angle BAC? That's gonna be one of your questions in your exit ticket, so you already seen it in advance, okay? All right, thank you. I know it took a while. I wanted to take my time and give you this information slowly today. So I wish you guys well and good luck. If you have any questions, you always can email me and or respond in Google Classrooms. We started something called office hours that was recommended to me. So at noon every day, I'm going to check your work and try to respond to some of your responses every day. But you always can, ask me a question anytime during the day, and I try to respond at that time as well. But 12 o'clock, I'll specifically be looking at some of your notes and some of your responses at 12 o'clock every day. Okay? So good luck, and make sure that you annotate, make sure you complete your assignments, and make sure you complete your exit ticket for today's lesson, okay? All right, take care, and I'll give you updates in regards to your curriculum. But if you're able to write this down, make sure that that circles and conics are going to be this unit, and then we're going to go next unit. We're going to do trigonometry with trigonometric ratios and cofunctions as well. And that's going to be after we complete the unit on circles. Okay. All right. So I'll see you guys later. Have a great day.